Ypsilanti Township, Michigan. Winter, 1943. The sky over the plant is the color of wet ash. Inside, the noise never stops. A mile-long river of aluminum, rivets, and men moving under sodium lights that never go dark because the shifts never end. At one end of that building, sheet metal is still flat stock. By the far end, a quarter-mile away, it is a four-engine bomber, wheels down, engines turning over for the first time. At its peak, Willow Run averaged roughly one completed B-24 every 63 minutes. By the time the war ended, this single factory had produced more B-24 Liberators than any other aircraft plant in history, becoming one of the greatest symbols of American industrial power. One roof, one assembly line, thousands of four-engine bombers that helped overwhelm the Axis with sheer production. Germany possessed one of the world's most advanced aviation industries and many highly skilled engineers. Germany relied on a vast network of aircraft factories and subcontractors. Yet no single German aircraft factory ever matched the scale and output achieved at Willow Run. How did one factory become one of the greatest symbols of America's industrial power? By the summer of 1940, the math of the war had already turned against Britain. The Luftwaffe assembled a powerful air force across occupied Western Europe, with thousands of aircraft available for operations against Britain. Although the Royal Air Force fielded far fewer frontline fighters, it relied on an integrated air defense system and home field advantage to resist the coming assault. Winston Churchill understood that Britain urgently needed more aircraft of every kind: fighters, bombers, and transports, and that domestic production alone might not meet the growing demand. The Royal Air Force faced shortages of both trained aircrew and modern aircraft, placing enormous pressure on Britain's aviation industry, so Churchill looked west, across an ocean, to a country not yet at war, to an industry that had never built a warplane at anything close to the scale this fight demanded. The United States produced just over 6,000 aircraft in 1940, far fewer than it would manufacture after full wartime mobilization. There was one man Churchill's people turned to who had already answered a question like this before. Though never for war, Henry Ford had built more automobiles than any man alive. He had done it by breaking a car into thousands of repeatable motions, each one simple enough that an untrained worker could master it in a day. Ford didn't build machines. He built the system that built machines, faster than anyone thought a system could move. Bombers were not cars. Everyone said so. A B-24 Liberator contained well over 1 million individual parts, thousands of them shaped from dies, thousands more machined to tolerances no Model A ever needed. Early B-24 Liberators required well over 180,000 man-hours to build using traditional methods. At that rate, America could never build the numbers the coming war would demand. Ford's own engineers were skeptical he'd even take the job. Aircraft men scoffed outright. You couldn't rivet a bomber wing the way you stamped a fender, they said. Tolerances were too tight, the parts too complex. The whole philosophy of aviation manufacturing built on the opposite principle of Detroit's: small runs, constant hand-fitting, expert judgment over repeatable motion. But Charles Sorensen, Ford's production chief, the man who had already re-engineered the moving assembly line once, flew to San Diego in January 1941 to see a B-24 built the old way. He watched skilled workers hand-fit parts that should have been interchangeable. He watched the bottlenecks. He watched a bomber take shape one aircraft at a time, the way violins are made, not the way tanks are made. Sorensen didn't see an impossible problem. He saw a familiar one, dressed in a uniform he didn't recognize yet. He flew back to Michigan and, within days, sketched the outline of a plant on the back of an envelope, a building that didn't exist, for a production system nobody in aviation believed could work. To build a bomber America hadn't finished designing, changes too. Ford would need to build the factory before it could build the plane. Many German leaders underestimated how rapidly American industry would expand once the United States fully mobilized. although some military and economic observers warned of its enormous industrial potential. The envelope sketch became a blueprint, and the blueprint became one of the largest factory buildings ever constructed under a single roof. Willow Run. They called it after the creek that ran through the farmland Ford bought outside Ypsilanti. The factory covered roughly 3.5 million square feet, and the complete production flow stretched for about a mile from raw materials to finished bomber. Locals joked that workers needed bicycles just to cross the plant floor during a shift change. Some weren't joking. Sorensen's plan was audacious on paper before a single rivet was driven. Where the aviation industry built aircraft in small batches, a few dozen at a time, each one hand-adjusted by craftsmen who knew every quirk of every airframe. Ford intended to build B-24s the way he built Model Ts, on a moving line with interchangeable parts, assembled by workers who each performed one motion over and over, all day. The target Ford announced wasn't modest. Ford announced an ambitious goal, eventually producing one bomber every hour. At the time, producing a four-engine bomber every hour sounded impossible to much of the aviation industry. Aviation executives called it fantasy. A four-engine heavy bomber wasn't a fender stamped from sheet steel. It contained well over 1 million individual parts, thousands of subassemblies, tolerances measured in thousandths of an inch, wiring harnesses that had to route through wing spars without a single crossed connection. Consolidated Aircraft, the company that had actually designed the B-24, doubted Ford could build one at all, let alone at automotive speed. The doubts weren't only external. Inside Willow Run, the problems arrived before the machinery did. Ford's engineers had to revise thousands of engineering drawings and redesign many production processes so the B-24 could be manufactured efficiently on an automotive-style assembly line. Ford's engineers then created more than 30,000 specialized tools, dies, and fixtures needed to manufacture standardized B-24 components on a moving assembly line. Labor was its own crisis, layered on top of the engineering one. Willow Run needed tens of thousands of workers in a rural stretch of Michigan with nowhere near that population. At a moment when every able-bodied man was being pulled toward enlistment rather than factory work, Ford would eventually have to recruit from Detroit, from the South, from farms 100 miles away, and increasingly, out of necessity rather than progressive intent, from women who had never set foot on a factory floor, taught in weeks to do work the aviation industry, insisted required years of craft experience. The plant that was expected to build a bomber every hour was still producing aircraft far below its planned rate. By late 1942, with the building finished and the machinery installed, Willow Run's production numbers told a different story than the blueprints had promised. The line was moving, but it was moving in fits, stalling at stations where mismatched parts refused to join, where wiring harnesses meant for hand-built aircraft snarled against jigs designed for speed, not patience. Newspapers that had celebrated the factory's opening now had a nickname for it, one that stung because it landed close to true. They called it Will It Run. Every fix at Willow Run started with the same brutal arithmetic. A single tooling error, multiplied by 1,000 aircraft, became a catastrophe instead of a defect. Ford's engineers spent the back half of 1942 doing something the aviation industry had never attempted at this scale, converting an aircraft designed for hand-fitting into one built entirely from interchangeable parts. Dies had to be remachined to tolerances of a few thousandths of an inch, tight enough that a wing spar built in one corner of the plant would mate perfectly with a fuselage section built a quarter mile away, by workers who had never met and would never need. Ford's engineers reorganized the B-24's more than 1 million individual parts and thousands of subassemblies into a production sequence that ensured each component arrived at its station exactly when the moving assembly line required it. It was, in effect, redesigning an airplane so it could be built by people who had never built one before. But precision alone didn't move a bomber down a line. Someone had to build the people first. Willow Run pulled in workers from Detroit tenements, from Kentucky Hill farms, from towns that had never seen an assembly line, let alone an aircraft factory. Many had driven or hitchhiked hundreds of miles on the promise of wartime wages. Among them came women in numbers the aviation industry had never planned for: riveters, electricians, inspectors, trained in weeks for work that supervisors had insisted, only months earlier, required years of craft apprenticeship. Women at Willow Run became part of the Rosie the Riveter movement, a national symbol of America's wartime workforce. Housing couldn't keep pace with the workforce. Some employees slept in cars, tents, converted chicken coops within walking distance of the plant, because Ypsilanti and Ann Arbor combined didn't have enough beds for the tens of thousands. The line demanded. Turnover in the first year ran so high that entire shifts sometimes trained new hires from scratch every few weeks, a workforce, assembling itself even as it assembled bombers, both processes still mid-collapse. 4,000 miles away, German industry made a wager it never fully corrected. That decentralization, not concentration, was the safer bet. Luftwaffe aircraft production stayed deliberately scattered across dozens of smaller factories, subcontractors, and regional plants, a hedge against Allied bombing that also meant no single German facility ever approached the density of tooling, labor, and throughput Ford was building under one Michigan roof. Much of Germany's leadership underestimated how rapidly American mass production would mature. Mass production of heavy bombers, American style, was a novelty project, not a threat. They were reading last year's numbers. By January 1943, Willow Run was running, but barely, and the gap between what the plant was supposed to do and what it was actually doing had become impossible to hide. Production remained well below expectations, and output fluctuated as engineering and supply problems continued. Government officials closely monitored the project as delays and production problems attracted growing attention. Some officials questioned whether Willow Run would ever achieve its ambitious production goals, and criticism of the project grew as delays mounted. The failures weren't abstract. Wiring harnesses built for hand-fitted aircraft still snarled at assembly stations designed for speed. Sub-assemblies arrived at their stations out of sequence, forcing lines to halt while workers waited on parts that should have already been there. Some early airframes came off the line with defects serious, enough to require near-total rework before they could fly at all. The exact opposite of the interchangeable parts promised the whole plant had been built around. Inside the Army Air Forces, officials closely tracked Willow Run's production figures, knowing that continued delays could affect bomber availability for operations in Europe and the Pacific. Ford himself, aging and increasingly disengaged from day-to-day operations, was not the one leading the effort to solve the factory's problems. That responsibility fell to Sorensen and a small group of production engineers, who focused on identifying and eliminating the bottlenecks that were slowing the assembly line. They chose to systematically redesign the production process, station by station, eliminating bottlenecks and improving workflow, with no guarantee the changes would succeed. The headline writers were still calling it "Will It Run?" Nobody at Willow Run, in January of 1943, could yet prove them wrong. The turnaround wasn't the result of a single breakthrough. Instead, it came from hundreds of incremental engineering and production improvements implemented over many months. Sorensen's engineers stripped the line back to its failure points and rebuilt them one at a time. Wiring harnesses were redesigned so they could only be installed one correct way, eliminating the guesswork that had jammed earlier stations. Subassembly schedules were resequenced, so parts arrived exactly when the line needed them, not before, not after. Dies that had produced marginal tolerances were recut, retested, and recut again until a wing spar built on a Tuesday fit a fuselage built on a Friday without a single hand adjustment. As engineering improvements took hold, workers were increasingly able to follow a standardized production system instead of constantly adapting to assembly problems. Throughout 1943, production steadily accelerated as engineering and supply problems were solved. In August 1944, the plant reached the milestone that had once sounded like propaganda. 428 B-24 Liberators built in a single month. At its peak, the assembly line averaged one completed B-24 approximately every 63 minutes, an achievement once considered impossible. As production reached record levels, early criticism of Willow Run largely disappeared, and the factory became recognized as one of America's greatest wartime industrial achievements. While Willow Run climbed, German aircraft production hit a ceiling it could never break through. Germany's decentralized strategy, dozens of smaller factories scattered to survive Allied bombing, had protected individual plants, but at a cost nobody in Berlin had fully priced in. No single facility could match the density, the tooling, or the sheer throughput of one American plant built for exactly that purpose. By 1944, Allied bombing campaigns were directly targeting the ball-bearing plants, refineries, and component suppliers that fed Germany's scattered aircraft industry. And because that industry was scattered, a single successful raid could cripple output across dozens of dependent factories at once. Unlike German factories, Willow Run operated beyond the reach of Axis bombing. German aircraft production could no longer keep pace with the expanding output of American industry. Fuel shortages grounded aircraft that did roll off the line. Skilled labor, once Germany's advantage, thinned as the war dragged more men to the front and left factories running on forced and conscripted labor instead. What many German leaders had underestimated in 1941 had, by 1944, become undeniable arithmetic. One country building bombers by the thousand, one line at a time, under one roof. The other building them in fragments, across a map, shrinking under the same bombers Willow Run had built. By the end of the war, the numbers stopped being a claim and became a record. Willow Run alone produced 8,685 B-24 Liberators, making it the most productive B-24 factory ever built and one of the greatest industrial achievements of World War II. Few factories in history had ever matched the scale and efficiency achieved at Willow Run. The United States built more than 18,000 B-24 Liberators during World War II, making it the most produced American heavy bomber of the war. Willow Run's workforce peaked above 42,000 people, many of whom had never worked a factory floor before the war began. Men and women alike, trained in weeks for a trade the aviation world had insisted required years. Post-war analyses concluded that America's ability to replace heavy bomber losses through massive industrial production was a decisive advantage during the strategic bombing campaign. Post-war records showed Germany struggled to match the sustained output of American industry as the war progressed. Willow Run became a symbol of American industrial power, and proof that in modern war, production could be as decisive as the battlefield itself. Willow Run cost more than money. It cost a landscape of farmland turned permanently industrial, a workforce built and rebuilt from scratch under wartime pressure, and a philosophy that anything, even a warplane, could be reduced to repeatable motion, proven true in a way that would outlast the war itself. Detroit's mass production methods demonstrated that many principles of automotive manufacturing could be successfully adapted to aircraft production, influencing industrial manufacturing long after the war. The workers who built the impossible thing are mostly gone now. The plant itself, altered and rebuilt many times, no longer looks the way it did in 1943. But for a few extraordinary years in Michigan, one factory became a symbol of the industrial power that helped the Allies win the air war. The number it left behind still sounds on paper like it shouldn't have been possible. It was.